Welcome to NMOP. We'll be starting now. So I'm Benoit. Reshat is online. Reshat, can you just test your microphone?
Hello.
Okay, this was Reshat. Next to me is Thomas. Thank you, Thomas, for helping. Thomas is secretary here, but since Reshat cannot join, thank you for helping out. We have two NMOPs. First of all, the Note 12, right? By attending and registering, you agree to follow all the guidelines and the policies in the Note 12. So we have two sessions. This is the first one, it's 1 hour. It's an in-person participant meeting. Make sure you log in, you're signing into that tracker. This is the way to go to the queue and ask questions. There is the QR code, or there was a QR code somewhere. Just go from the IETF website, agenda, you click on NMOP and Meet Echo. If you are, there is an application, the light application that you could use in the room. Make sure if you remote that your microphone is off unless you're talking. And the headset is greatly appreciated. We don't have any remote presentation this time, so we should be good. So we need a volunteer for the meeting minutes. And I designated two volunteers who kindly accepted, not even twisting their arm too much. One of them went out late yesterday evening, so we'll do his best. So there are two of them, Dan and Mike. I'm not telling which one went out. So feel free to help. So if you go to the microphone, please check in the meeting minutes just after that it was correctly captured, and please help with the meeting minutes. Thank you very much. And also state your name in the microphone, even if we might be seeing your name in the queue. So the agenda, as I mentioned, this is the first meeting. The second one is on Friday. This one is 1 hour. Typically what we've been doing and why we've been having two sessions is this, because in this charter we have the notion of experiment, which means hackathon, and historically we've been having the hackathon aspect in the second part, the 1 hour. However, we start combining the different sessions per project. This is the P2 that you saw maybe in the agenda, which means that everything this is, today this is related to network anomaly and incident management. And historically also, and something that we are proud of, is that we've been having like operators coming to this session to share live incident information, not specifically the details about IP address and all this, but the problem they have, and this has been helping us with the documents. So we are proud to have China Mobile and China Unicom this time. So these are the last two sessions. We will go after the agenda bashing for network anomaly detection with Wanting, who's been covering 3 different documents. And after that, Chin will be covering the Yang data model for network incident management. So any agenda bashing? All right, hearing none. So Reshat, did I forget anything so far? And if you want, you can go to the document status.
Yeah, so on the document status, we have the Yang message broker message key, which was adopted after IETF 124. Thanks for everybody who responded. CMAP concept working group last call is completed. Thank you for Olga for so diligently tracking those issues, and for the working group, for all the comments, because without comments from the working group, a working group last call is fairly meaningless. And we still have the terminology doc in the editor queue. Next slide. So that's the milestones and what our current plan is. Next target is to get CMAP to the IESG. And then after that, the message broker integration doc and then all the anomaly ones. Right on time.
Perfect. So we could be starting with the first presentation. Miss One Thing, if you want to come on stage. Oh, shit. So, click is still, yes. So, can you help me with remove now the slides? And this is where I don't recall how I do that. It's here. Okay. And I know I have to unshare the slides, but I don't recall where the button is.
I think that's the fourth button from the left at the bottom. If you click that, no, it doesn't work.
No.
So
We
your
have an. Yeah, but je ferme.
Tu fermes là. Ah, et après t'achètes le truc.
ADs are very useful people. in architecture.
Hello everyone, I'm Wan Ting from Swisscom. Today I'm going to do a presentation about the latest change on the following three drafts. They are all relevant to network anomaly detection, and they are all adopted in NMOP working group since long time. And yeah, it's a collaboration between academia, between vendors and operator. Yeah. So yeah, let me first start with the problems we're addressing here and the relationship between these three drafts. The first, so our goals were simple. It's we want to detect service interruption early, and then second, we want to describe the anomaly, network anomaly correctly and consistently. The last, we want to continuously improve the ability of our network anomaly detection system in a automatic fashion. So here's we come with the three drafts, address each different issue. The first draft is the architecture part where we believe we need automated and holistic monitoring across all three network planes. So in this draft, we describe the motivation and the architecture that reflects this mindset, and also we describe the relationship of this draft to other two documents. The second draft about semantics, we define the semantic symptom semantics to enable standardized data exchange and benchmarking, and in order to improve continuously network anomaly detection abilities, regardless it's supervised or semi-supervised learning. In the last draft, it's about lifecycle. We think we need a lifecycle that automates the postmortem system and connects network anomaly detection and also the actionable operational task. So with this lifecycle, we define how network engineers should interact with the network anomaly detection system in order to refine the detection ability over time. Let's start with the architecture draft. I will do the recap to describe the motivation and our approach and outcome. So the motivation is simple because nowadays we believe the resource level monitoring and human-driven troubleshooting doesn't scale due to the growing number of dependency of each resource and also the massive amount of data. And we want to automate this process. So this draft defines a standardized architecture level framework, um, and in order to enable the automated service disruption detection. On the right hand, you have a small figure describing the architecture. We specify in the draft the requirement for each component in that architecture, the data flow and the interfaces of each component. It serves as a blueprint for designing and implementing a network anomaly detection, ensuring that they are comprehensive, scalable, and effective in real-world operational environment. So here's the latest updates since the last IETF. We have some terminology updates, such as we changed the customer profile to service profile to ensure the consistency across different documentation, especially the RFC 8969. We also added a formal rules definition in terminology part to distinguish between knowledge-based approach and machine learning approach. We also did some restructuring of the draft. We reorganized the service disruption section to improve the general reading. And some minor refinement also applied. We clarified the relationship between semantic rule and knowledge-based detection. We refined definition of collective outlier, confidence score, and concern score. We also refined some clarification like alarm raising criteria, data storage consideration, operational data aggregation, and so on. Last but not least, we have also explicitly outscoped the service degradation based on a working group review. And as an operator, we want to demonstrate how this architecture is implied in industry. So this a real incident happened last month in Swisscom. We have a TV service which was severely impaired during 6 hours due to hardware failure and then triggered a software defect, which altogether led to denial of service condition. On the right hand, you have two figures. It's the operational data during the incident time. The first one is the BMP update and withdrawal message amount. So we see this continuous curve, which is outlier. And also the second figure, that is the traffic view. We see less traffic during this incident, and that's straightforward. It's anomaly. And this is what we observe with our anomaly detection system. We generate alerts which can be trained. It's a combination of multiple time series data. Each time series data is concern score for expert rule from 0 to 1. So the higher it is, the more concerning it is. And they all together aggregate, generate overall concern score at 0.53, which is quite high and corresponds to a severity level of major to critical in our setup. What we see from here is like we have implemented multiple expert rules on different network lanes. And we, among all these rules, there's 3 different rules were triggered during the incident time. And I think that confirms the value of multi-plane detection. So now we have the anomaly, but we believe that it's not enough because anomaly should be understood and also exchangeable. That's why we come up with this semantic draft. And the motivation is to enable the exchange of network anomaly data across diverse systems and support benchmarking of different anomaly detection solutions. In approach, in this draft, we define a standardized semantics metadata schema to describe anomaly and the set of semantically structured terms to describe different network symptoms. And this is to provide human readable context for describing and understanding network anomalies. And the key updates since the last IETF for this one is we have some terminology updates. We added some missing definition for the draft, such as the concern score and symptom. And most important change to this version is we changed the schema. from least important to most important, we removed some unused type def score. And most important is we refined the VPN node termination grouping. We introduced new leaf in that grouping, such as VPN ID and VPN name, VRF name. And also we changed the key of this leaf list. So before it was the combination of host name or the route distinguisher. Now we change the route distinguisher to use the VRF name. And also the third schema change we introduced here is we use now a dedicated layer 2 and layer 3 grouping for service instead of using the one single grouping for two types of service, just to distinguish between two types. And also we have updated one symptom in the symptom table on the data plane. It's the symptom about packet drop outside the monitoring domain. Before it was described as with the reason previous and the trigger time. Now we change to drop and reason with trigger with outside monitor domain, just to increase the clarity and the consistency across the draft. Also, last but not least, the arrow schema we provide also changed accordingly to address the recent change on the YANG module. Here's a snippet of message coming from our anomaly detection system implementation. We can see the new schema is applied. We see some field like VRF name, what's introduced this time. And also in the service, we see the type of service. You note that they are still placeholder because now we are just trying to prove that the schema change is valid and is implementable in the practice. And now we come to the last draft, a lifecycle draft. The motivation for the lifecycle is we want to bridge the gap between automated network anomaly detection and actionable operation task, whether it's to improve the anomaly detection system or benchmarking and so on. So the approach is to define a standardized and iterative lifecycle for network anomaly, so human can interact with the anomaly detection with the human in the loop feedback, so it can continuously improve the correctness of anomaly detection system. The latest change is we also changed terminology. We streamlined the state or phase, which were both used in the draft, to use stage to avoid confusion with the term state, which is usually used in the network protocol. Also, schema changes, we have also changed the state to stage, of course, to reflect the terminology change. And a minor fixing for the RFC 8407 for the young warnings. And also, most important, we have included a new operational data reference in the anomaly with the new grouping called message broker grouping that is used to link the analytical data to operational data. This comes from the experience of our implementer of the lifecycle implementation, and we believe it's important to link operational data to the analytic data with this reference. And some other refinement also applied. We refined the definition of confidence score and concern score, refined a bit of the figure, and consolidate the usage of score across different drafts. Yeah, and that's all for the updates. So for the next step, of course, we will first request Young Doctor to review the new Young module in these two different drafts. And for the implementation part, we will replace the placeholder in the anomaly with newly introduced fields with the corresponding value, including the site IDs, interface name, and VRF names. And also for the lifecycle draft, we also plan to do some implementation. So we want to extend the post-mortem system requirement together with the implementation of proof of concept in the near future. So yeah, last but not least, we would request some editorial review from working group. We actually received already some editorial comments from Rishad. I will be addressing them soon. So no remaining issues so far. Any feedback is welcome. Thank you.
Any question and feedback? And by the way, for next presenters, the time allocated includes the Q&A as well, which is equally important.
Dan Cisco,
Hello.
in your motivation and your slide 3 and 4, you mentioned troubleshooting does not scale with nodes and so on. So far with the architecture that you have, how often and what's the percentage of time that you are able to find the root cause without having engineers to log into the network? Is it most of the time, or is it?
Nowadays, I don't have the exact statistics, but without the current monitoring solution, it will be taking much more time. Yes, so you have to, at least with the current monitoring system, you can have a big picture, and just within 1-2 clicks, you can locate to the specific node, the possible problematic node, and that helps you to decrease the mean time to repair effectively. However, we don't have really a statistics that I still believe, yeah, for the moment, it's not yet, I would say, closed loop 100%. You still need some engineers to check the node, the device, but that avoids, that is, that it limits a lot of false choice. So people doesn't need to log one by one. They know where exactly to check.
Yeah, my question was not really in
let's be quick, right?
changing config, but more if you have to log to actually know what's going on or not. It would be nice to have some stats. It could motivate the whole community on this type of architecture.
Yeah, that's why we need maybe life cycle draft.
Hello, Chung Feng
Hello.
from China Telecom.
Yeah.
Thank you for your presentation. I think the framework you introduced is data-driven, and you have done a great job in this regard. I have a question related to the AI technology in network anomaly, anomaly detection. Yeah, well, as I know that AI technology has been introduced for network anomaly detection. For example, multiple AI agents can collaborate to solve the anomaly problems. And so my question is, how do you think how to integrate AI with the framework you introduced? Is there should be an interface between the AI system and the framework, or AI components should be integrated in your system? How do you think about this?
Thank you for your question. I think is a good point, and it's also one of the direction we want to go. I think it's, of course, a really valid point, and we should have an interface that interact with the agent that could do one step further to do the analysis, or even closed loop. Yeah, I think that's a good point. Maybe we can also consider.
Thank you.
Yeah.
We can have more discussion.
Yes, please.
Okay, thank you.
Thank you. So Chin, if you want to come. So we're good. So actually, I hate to be the painful guy telling that we have to speed up, but whenever you put the time, it's a message to the speaker. Please make sure you leave time for the Q&A, which is sometimes to me the most interesting part of the session. Thank you.
Morning, everyone. And I will give update of incident young data model. The current version is 08. Okay. So since last IETF meeting, Montreal meeting, we actually received a couple of comments from Rashad and Daniel King, and also Benoit class. So this latest version, actually, we try to address all these comments. You can see the latest update, including, for example, yawning the issue, and this raised by Rashad, and we fixed that. And we also try to align with template and security consideration template in the obviously 8407 bits. And also based on suggestion from my class, we capitalize the terms in section 2 and also fix a editorial issue raised by the Dan. And thanks for that. And in addition, we actually try to clarify relationship with several relevant jobs. One is about OM test scheduling. Second is about network anomaly detection architecture. And also we, based on early discussion in the previous meeting, we talk a lot about, incident responsibility issue. So we try to clarify the role of incident client and incident handler, and try to distinguish their responsibility. And so first, the question more about where to resolve the kind of incident, whether it's in the incident client or incident server. Actually, so proposal we made is to try to refine the definition for incident client and incident handler, and we only we think incident client have control for the we don't instruct the incident server to perform network incident diagnosis and the resolution. So, but the incident handler, they don't have such kind of control. So you can see the figure, the big difference. So in addition, actually, we also propose some further text and try to clarify, incident client can have more global view on the network topology data, and also incident client and instruct the server to resolve the incident. So this is a clarified text that we made. So this is the first issue. Second is about try to clarify relationship with the schedule OM tester. So this is based on offline discussion, and we think this schedule OM test can also be the good data source can be used to connect the network diagnose information for data analytics. So we reflect this point in the latest version text. And we also clarify relationship with the network anomaly architecture based on my comments. In some cases, network anomaly detection system can also use together with incident management system. How, especially they can be used in the same controller. So we give the example to show how it look like. And you can see this. We actually have network anomaly life cycle and semantics, and life cycle defines the IETF relevant state model, and normally semantic define two other model try to extend from the relevant state. You can see where this model can be used. So we think yeah, go to the next. So we think yeah, this incident network management and also network anomaly detection can be used together. And we see currently, for network anomaly lifecycle, they only provide possible solution to connect anomaly information, report to the incident server, and go step further to the incident client. Second, anomaly lifecycle more focused on human in the loop paradigm, rely on the network engineer to interact with the network anomaly detection system to refine the detection ability over the time. So we propose, I think I make some mistake. I try to make it, two jobs to cover, but we can add one section to clarify how, incident, network incident young data model relate to the network anomaly architecture draft. So here's we propose the solution. So we add a new section 4.5 to clarify how this can be related to each other. We think network anomaly detection system can connect quite a lot of anomaly information or symptom information. only when this information, cause some disruptive change for the service, we will upgrade to the incident. So, so this is our proposed text to address these comments. Yeah, I think, yeah, this is all what we have for the proposed changing. We address, all the comments we received have. And any comments, Rashad?
Yeah, so have you discussed this with the anomaly architecture group of authors, or is that proposal coming just from the authors of Incident Yang?
About which issue?
Well, about this, I mean, your previous slide was showing how you feel Incident Yang should interact with the anomaly architecture set of documents. So I just want to know whether you've discussed this kind of interaction with them, or whether that's coming just from the, okay, so I basically want to make sure it's not just from a few people who are proposing that, but that the anomaly architecture authors are also in.
Yeah, I did have offline discussion, but this issue raised by my class, he think, for anomaly detection and incident management, they have, some cases can be used, used together in the same controller. So I did have, offline discussion with many anomaly architecture proponents, like Vincent Zhou and also, Thomas. And so this is something, yeah, I should have raised
Okay, good. No, I think you answered I mean, I saw the comments from Benoit. I knew they came from Benoit. I just wanted to make sure that the other set of authors had been involved. Okay, thank you.
Thomas, as an anomaly architecture author, I will review what you're proposing and will feedback on the mailing list. Huh?
Thank you. Thank you. Great.
Very good. So as contributor, I believe this change makes sense. And if we speak as, you were in the onsen buff, right, where we want to somehow use, we discuss about mapping and all this, I think it makes sense. But also to come back to the first three drafts we saw, there was also the notion of L2 VPN, L3 VPN in one of the drafts. I'm going to put it on the mailing list, but this is also something that might want to look at in thinking about onsen, which is reusable component. I don't want to say that we want to wait for the working group because it becomes to the AD, but maybe there's something we could be doing there. Thank you. Thank you, Jim.
Thank you.
Next one is. Just 1 second, but feel free to start.
So, hello everyone. My name is Zhenqiang Li from China Mobile. It's my great honor to share China Mobile's practices on IP autonomous network. The use case I share today is automatic IP network traffic steering. In network OEM, there are two core objectives: alleviating network congestion and assuring the quality of differentiated services. They both rely heavily on efficient traffic steering. For traditional traffic steering, our OEM staff had to consider a lot of factors, which places extremely high requirements on our OEM staff in terms of both professional expertise and a sense of responsibility. So our IP network traffic steering solution has achieved a paradigm shift, evolving from fully manual to semi-automatic and now to fully automatic. In the fully manual stage, our OEM team had to do everything, monitoring network status, analyzing the collected data, simulating the traffic steering effects, making steering policy decisions, deploying the policies in the network, and verifying their effects in the network, and even revoking them when they are not needed. For example, when the link congestion is relieved. In the semi-automatic stage, our IP network management system took over automatic network status perception, data analysis, steering policies, simulation, and generation. But the rest still needed human intervention. Today, the entire process is fully automated by our SDN controller, including steering policy deployment, verification, and revocation. So this is what we call a dark knock. Everything is done by our steering system, no human intervention. This paradigm shift delivers a dramatic improvement in steering efficiency and quality, while transforming our steering mode from reactive firefighting to proactive incident prevention. In terms of labor cost savings, our system saves the labor cost equivalent to the work of 6 full-time OEM staffs. Currently, our IP traffic steering system is mainly applied in 2 key scenarios, congestion steering and differentiated service steering. For congestion steering, it's designed to precisely divert traffic to resolve network congestions caused by traffic increases in rush hours, network failures, high performance, high traffic hot events such as the Chinese Spring Festival or natural disasters. For the differentiated service steering, its core goal is to guarantee the service quality indicators, including low latency, high bandwidth, minimal jitter, and minimal packet loss. So this slide showcases our system core workflow for congestion steering. As discussed with working group chairs, due to our internal regulations, I cannot disclose our actual instance and with real node names or the specific service impacts. But the demo video embedded in this slide is driven from our real instance and is intended to illustrate the capability and workflow of our steering function. Our product system automatically generates more than 100 steering policies every day to alleviate congestions in our network caused by rush hour traffic increases and network failures. So when our controller detects the utilization rate of link exceeds the pre-configured threshold, it will automatically trigger the steering process. A concrete example is shown in the video, but unfortunately it doesn't work now. I don't know. The utilization rate of the link node from node A to node B reaches 28.5%, which surpasses our 80% pre-configured threshold. That's when the steering process starts. First, our SDN controller uses intelligent algorithms for data analysis and network simulation, with the goal to select the optimal detour path and to identify the appropriate target traffic flows to be steered. Next, based on the simulation results, steering policies are generated and are automatically delivered to node A, redirecting the target traffic to node B, where node C and node D. So right after policy deployment, our system launches an immediate verification process. It not only ensures that no routing loops are introduced in our network, but also confirms that the utilization rate of link AB, link ADB, and link ADB all stay below the specified threshold. If verification fails, the deployment policies are revoked immediately. If it passes, the entire steering process is deemed to be a complete success. In the example shown in the video, the utilization rate of link AB is successfully reduced from 82.5% to 56. I don't know. Once rush hours end or a network faults are fixed, network congestion eases, then our SDN controller will automatically revoke the previous deployed steering policies and restore the network to its original state. Our system has been running stably in our live networks for more than 5 years, covering 31 provinces across China. This system provides us substantial OEM benefits. According to our estimates, eliminating congestion from our backbone network purely through network capacity expansion would require an additional 50 terabits per second of total network capacity. By deploying our automatic network traffic steering system, we have built a congestion-free state highway, ensuring that our business clients experience zero service degradation and zero network disruptions.
If you want, I'm going to share from the PowerPoint to see the video, or maybe you can just send the video link to the network, to the NMOP mailing list. What do you prefer?
The video is embedded in
the PowerPoint, but not
yes.
the PDF.
Oh, this is.
Yes.
Oh, sorry.
So you will send the link to the NMOP mailing list, right?
I sent the PPT version to maybe Thomas and you. It doesn't.
Okay, I share again the PDF. Just 1 second.
We could continue.
Okay.
So for the enabling technologies, most of them are dependent in IETF. We use BGP-LS link state to collect network topology. T1 is used to measure the performance of each link in our network. In our network, T1 test packets are sent every 100 milliseconds. Telemetry is used to subscribe the performance data, including the utilization rate of each link and the test results of T1. Currently, every 30 seconds, our T1 measurement results are reported from routers to our SDN controller. Over the past 2 years, we have completed IOM trials in our live network. Both our routers and controller now support this technology. We will use it to measure the performance of our key services and to quickly locate the cost and position any service degradation. Digital twin technology is used to simulate and verify the steering policies, ensuring their effectiveness before deployment. We use SRv6 to deliver differentiated services. SRv6 policies are generated by our SDN controller and automatically delivered to the headend node in the network via BGP SR policy protocol. BGP flow spec is used to redirect the public network traffic to a specific link or SRv6 policy. Netconf is mainly used to configure layer 3 VPN and layer 3 eVPN service instances. At present, the BFD and SBFD parameters associated with the SRv6 policies are also configured by Netconf. In the end, I'd like to briefly walk through our related standard efforts in IETF. We have published micro-2amp and the micro-stamp as RFC 9533 and 9534. They provide mechanism to accurately measure the performance of each member link in a link aggregation group. And the others are the working group working atoms we are trying to do in the IETF. I'm not sure I have enough time to go through them. So that's all for my sharing. Thank you so much.
Dan Voyer, Cisco. Very interesting, your presentation, especially on the very first slide where you say dark NOC, fully automated. Do you have a timeline? When do you think this is going to be reality? And did you already spot what's missing to get there, or is there any challenge to get there?
It is already the reality. We have used this system in our product networks for more than 5 years. It is not a dream.
So
it is the reality.
Fully automation, dark NOC is real for you today?
I mean, for IP network traffic steering, it is fully automatic. From network status perception to steering policy revocation, the entire process is fully automatic without any human in the loop.
Very well. So maybe I don't want to take too much time, but this is amazing. If you have a use case, if you want to come back when you had an outage or something, and you can demonstrate how the fully automated, when it will be very appreciated in the list.
This is a demo video, but it doesn't work. It should be the PPT version. I'm sorry.
Paolo Lucente, NTT. In the enabling technologies slide, you had telemetry. I was just curious what telemetry is. What telemetry?
Telemetry is used to subscribe the performance data from the network, including the utilization rate of the link and the measurement result of 2amp.
I think he's asking about which technology you're using.
Exactly.
Which technology for telemetry you're using?
gRPC.
Oh, any plans using
with GBP format?
Any plans using Young Push?
No, not yet.
Okay.
Thank you very much. One quick one. The last slide you had, like where you involved, right? My question is the reverse. Do you believe the NMOP documents are useful to what you want to do? And do you have any feedback on this? And feel free to answer on the mailing list if it's a longer answer, right? You decide quickly if you want to reply quickly. Is the work we're doing in NMOP useful to you?
The work we are doing are mainly related to the work in IDR. So,
okay, thank you.
Hi everyone, I'm Jing Zhao from China Unicom. Today it's my pleasure to be here to share incident with China Unicom. First, I will introduce the overview of China Unicom's IP network. As a leading integrated telecommunication peers in China, we has established in 31 provinces across China, as well as in many countries and regions overseas. So the composition of the core IP network architecture, including the China 169 backbone network, metropolitan area network, CUI industrial network, and the smart metropolitan area network, IP bear network B, and the others. Today, I will introduce the 4 types faults in our live network. The first is physical fault, site outage at the SIM feed code. The symptoms is melt OTN and IP run loops in the local transmission network entered open loop states. This caused the equipment disconnection and the subsequent partial base station outages. During the process of we looked the problems, we found that the on-site verification confirmed a physical optical cable card at the predicted fault location, and the outage affected 2 main core optical cables. And the reason why is 2 OTN loops with the SIM ring network locked physical separation in their optical cable routing. Introducing a vulnerability refers as a single path sharing of a single physical node, a single optical cable card, then trigger a dual link fails of both OTN loops. And the next is configuration fault. We conducted a new VPN service cutover on a core network device. During the cutover, the network management systems generated a large number of alarms. Many of the 4G and 5G base stations reported link down alarms. This incident often only impacted the base station monitoring and did not affect the data forwarding services. During the process of we identified the problem is inspected the 4 and 5G management VPN routing tables on the other VPN nodes and found that the static router were invalid. Verified the operation logs on the core devices. The original VPN configuration on the designated loopback interfaces was overwritten due to a script conflict with the live network. We reconfigured the original VPNs on new loopback interfaces and the service was fully restored. The reason is during the cutover, the new VPN configured on the loopback interface conflicted with the existing 4 and 5G management VPN. The old VPN configuration was overwritten and its rules on the core nodes were withdrawn. All related routers become invalid, causing all base stations to lose management connectivities. The next is resource-based fault. Some users reported abnormal voice calls, unsubscribe rejection success rates, and core completion rates both decline. So we joint verification confirmed the following. We found that the norm traffic path is mobile core node to bare core node to bare access node to 4G radio network to terminals. We found the link congestion and packet loss occurred between bare core node and the bare access node. The reason is an OTN company upgrade many devices online at the same time, resulting in abrupt and massive traffic surge. The native layer failed to detect the traffic increase in advance and did not implement rate limiting or bandwidth protection in a timely manner. The traffic exceeded the link capacity, causing congestion and packet loss. Single in mobile core network was lost and retransmitted. And the next is correlate fault. A city level router was configured with static routers associated with BFD for fast fault detection. Frequent optical link flapping causing the static router to become invalid. The link flapped frequently and recovered automatically, although the BFD seasons remain off. The static routers were not reloaded into the following agent, resulting in traffic interruption. The reason is due to the extremely short flapping interval, the BFD state transient up to down to up to rapidly to be synchronized with the hardware in time. This causes root intel loss in the fab and inconsistently between the control plane and the data plane. So what should we do? We might try to enhance the network resilience in a targeted manner for direct fault scenarios. For example, in previous event, the conduct simulation verification on configuration completes and the traffic bearing capacity before the network cutover or modification. And the in event master the important is rapid fault detection, and the important event once a fault is detection, the MELT team joint troubleshooting mechanism should be actively immediately to quick locate the fault and implement emergency survival restoration. And about this, we submit a document, and your interest and comment are welcomed. That's all. Thank you.
Thank you very much for sharing your incidents. Much appreciated. Any questions from the room? I see Rashad there.
I have a question on the BFD one, which was I think the last one. So that was a bug on the device vendor, right?
Yeah.
So I'm trying to think as an operator what can be done about this specifically, and I can't think of anything except okay. Thanks for confirming.
Hi, Niels from Deutsche Telekom. Thank you very much for sharing that. That was very interesting. Concerning your first example where you had the OTN outage, I mean, all of us operator have been there, yeah? That's a very typical case that we see. Do you use some simulation inside China Unicom to simulate to have non-sharing risk link groups?
Sorry, the detail of the the issues is not suitable to discuss here, and I will share it with email if you are interested in
Yes,
about it.
we can do that offline.
Okay.
Thank you.
Yeah, Hamen to here help a little bit on the question. Yeah, I really love the approach that we decompose the question into middle and afterwards. So simulation is something beforehand stuff. It could be used for a kind of what if I do this and that, what will happen network? But this kind of about fault, something already happened, or kind of middle or afterward. I believe all the sessions have their own multiple level of networks.
Thank you very much for coming. We're happy to have 2 new operators coming to NMOP to share that incident like we saw this one. Thank you very much to all. This is the end of the meeting, and see you for the second meeting, which is Friday. Thank you.